We have compiled a list of studies to include in our systematic review, and now it's time to determine which outcomes each study can contribute to. Each included study can offer insights into one or more outcomes. It should be noted that data from random clinical trial and non-random clinical trials should not be mixed together, even though they may contribute to the same outcome. For instance, if both randomized clinical trial studies and non-randomized clinical trial studies report on survival rates, these should not be pooled together. As a result, we will treat them as two distinct outcomes. It's important to note that MetaIMU can accommodate up to 6 outcomes. If you have more than 6 outcomes, you will need to start a new project. Let's assume that we have 6 outcomes, and these are their definitions. Reference 1 shows the final list of included studies. This is the same table from Step 3A.5, presented again here to facilitate the subsequent steps in Step 4. For Outcome 1, let's assume that we have 4 types of treatments. They are placebo, drug A, drug B, drug C. For the type of data, there are 4 options: continuous, binary, incidence rate and generic. You should choose the correct data type depending on what data you have. For example, if you choose continuous, you need to have mean, standard deviation, and sample size data. Next, we need to select the reference group among the treatment type that you stated. In this case, it should be placebo. Tolerance, I will put 0.01 as there are 3 or more arms. Now I need to select study that can contribute to this outcome. For this demonstration, I will select study 1, 2 and 3. Once I click this button, the data_outcome1_NXLSX file will be created in the directory. Open the file in directory and fill in accordingly. The study label is automatically filled in by MetaIMU. The treatment column will have drop-down that you can select, based on the treatment that you listed. The mean, SD and sample size should be filled up by you. By default, MetaIMU will assume that all study will have 2 arms only. Thus each study occupies 2 rows. However, some studies may contribute to 3 arms or more. In that case, you will need to insert a row manually. For example, for Kreckler 2025 and Johnson 2025, let's assume that they are 3 arms. We will need to add rows. Now, let's fill the data in. I will randomly fill in some values here. For outcome 2 until 6, these are the values that I set, and I have filled in the data beforehand to save time. If you wish to read the details, please pause the video. I will open the data_outcome_NXLSX one by one for you to take a look. Again, if you wish to, please pause the video. Furthermore, if the type of data chosen is generic, the data entry will be a bit different. We will use outcome 6 for this example. For this example, we assume that we have 3 outcomes: placebo, drug A and drug B, and placebo will serve as the reference. Assuming that study 1, 2, 3, 4 should be included for this outcome, we create the data_outcome file. Now, let's open the data_outcome6_n file from the directory. We can see that the layout is different from before. For generic data, we need to select the treatment and control and provide the effect size and standard error. Let's say for June 2023, we only have one arm, which is drug A and placebo. We choose this and put in the effect size and standard error. I will simply key in some data here. For Kritanawong 2022, let's say that this is a two-arm study that involved placebo, drug A and drug B. Then we will need to have 3 comparison. Let's add 2 rows now and put the same study label. The comparison we need to have now will be drug A versus placebo, drug B versus placebo and drug A versus drug B. Do keep in mind that it is compulsory for multi-arm study to have a closed loop. For example, in this case, the drug A versus drug B comparison must be provided. If these comparison is not available, even though the study provide the drug A versus placebo and drug B versus placebo, this study cannot be considered as multi-arm study. It should be noted that if the rows have same study label, they are automatically assumed to be part of a multi-arm study. Let's say Bagnardi 2015 has drug A versus placebo and drug B versus placebo but doesn't has drug A versus drug B. As mentioned just now, this doesn't has a closed loop, so it is not a multi-arm study. Hence, they cannot have the same study label. We will need to change the study label a bit. Let's call them Bagnardi 2015 drug A and Bagnardi 2015 drug B. Another important point to take note of is that when the data is generic and in ratio such as odds ratio, relative risk, or hazard ratio, you must enter natural log of them as the effect size. Meta-IMU provide a simple calculator to help you with this. In step 4.2, you can select the input type. If you choose raw binary data, then you will need to key in the number of events for treatment group, its total sample size, number of events for control group and its total sample size. Once you click calculate, you will be able to get the raw odds ratio and raw relative risk. But you should not key in these numbers into the data_outcome file effect size and standard error. Instead, you should key in the number of ln OR and ln RR here. For standard error, you can directly obtain here. The same goes to raw continuous data and raw incidence rate data. Just provide the necessary data and use this calculator. If the study provide odds ratio, risk ratio, ratio of means or hazard ratio directly, go to pre-calculated effect size and CI. Choose the type of pre-calculated effect size that you have. Select the confidence interval level given by the study. By default, it is set as 95%. Then key in the effect size value, lower CI and upper CI values. Then click calculate. Again, you will get the effect size and standard error values that you should put into your data_outcome file.